Let's solve this managerial economics question together. So you have this question on the optimization. So we are going to use Lagrange multipliers to solve this particular question. All right, so now the question says that a firm has been contracted to produce a total of 1,900 units of two goods, K1 and K2. The joint total cost equation for the production of the goods is given as C K1 K2 is equal to 100 K1 plus K1 K2 plus 100 K2. So that's for the joint total cost function. Then they also went ahead to give you the demand equation. So the demand equations you have for two commodities. So for the first one, you have the P1 to be 500 minus K1 plus 1.5 K2. Then for the second one, which is the P2, you had it to be 300 plus 1.5 K1 minus K2. All right, then they said where P1 is the price of good 1 and P2 is the price of good 2. All right. Then the I says that you should find an expression for the firm's profits. All right, so this is quite a lengthy one, but then we'll try and take it step by step so that you don't get confused at any point in time. All right, so now what do we know? We know that profit is total revenue minus total cost, right? You've already been giving you the cost function. They gave you the joint total cost function. But then note that first, let's even understand this question. They said that the firm has been contracted to produce a total of 1,900 units. So a total of 1,900 units. So he can't exceed this 1,900, meaning that this is a constraint. He's producing two commodities, so both of them cannot exceed 1,900. So let me even write it better. So for this one, I can say Q1 plus Q2, both of them should be equal to 1,900. He can't exceed the 1,900 because it's like someone has given you money to produce with this particular amount or start a business with this particular amount. You can't exceed it. You get. That's why we have to use Lagrange to solve it because of the constraints. So anytime they've given you a particular number that you have to produce with, then know that you are constrained. You get it. So both of them don't have to exceed the 1,900. You get it. And he's also producing two commodities. That's Q1 and Q2. You get it. But then they've given you the total cost for both of them. So it means the total cost, when you add this and this one, it would give you 100 Q1 plus Q1 Q2 plus 100 Q2. So that's for the total cost function. But then for the revenue, they didn't give you for both of them. They gave you for each of them separately. You get it. They gave you the price for the first one, which is 500 minus Q1 plus 1.5 Q2. Then the second one, so they give you a separate one. You get it. So since you know that the profits is equal to total revenue minus total cost, we already have the total cost function, the joint total cost. So you also have to find the joint total revenue function. But then they also didn't give us the total revenue function. They only give us the price. Do you get about with the price? You can easily find for the total revenue. So we know that total revenue is also equal to price times quantity, right? But here lies the case where they've given you the price for each of them separately. So we have to do for each of them. You get. So we are going to find the total revenue for the good one. So let's assume that it is Gary and sugar that is selling. We want to find the amount that is going to get for the Gary. Then we'll find the amount that you get from the sugar. Then we'll add both of them. So let's assume that this one is Gary. So the total revenue for the first one. So TR1, which is the first commodity, should be P1 times Q1. Do you get it? So the first one, P1 times the Q1. This is for the first one. So our total revenue one should be equal to P1. They already give us the P1. So our P1 is 500 minus Q1 plus 1.5 Q2. So all this is for our P1. You get it times Q1. So times Q1. So I can put this in brackets. So now let's simplify this. So it means our total revenue 1 or our TR1 should be 500 times Q1 should give us 500 Q1. The negative Q1 times Q1 should give us negative Q1 squared. Do you get it? Then plus 1.5 Q2 times Q1 should give us 1.5 Q2 Q1 or Q1 Q2. Do you get it? So that's for our TR1. Now let's also find for our TR2. So I can say that, I don't know if you should do it here or here. Okay, let me do it here. So I can also say that TR2 will be equal to, just like this one, TR1 was equal to P1 times Q1. So TR2 will be equal to P2 times times Q2. So our TR2 will be equal to, our P2 was given to us as 300 plus 1.5 Q1 minus Q2. Alright, so that's our P2, then times the Q2. So you can put this in brackets, then times Q2, right? So our TR2 will be equal to 300 times Q2, give us 300 Q2. Then plus 15 Q1 times Q2 give us 15 Q1 Q2. Then minus Q2 times Q2 would give us negative Q2 squared. All right. So now we have our total revenue for both of them. So it means for the first one, let's assume that this one is Gary. We are getting this from Gary. For the second one, let's assume that it's sugar. We are getting this for sugar. So now we have to find the joint total revenue function. So I'll know what you are going to get from both of them. So you are going to add this plus this one. Do you get it? So now our total revenue will be equal to TR1 plus TR2. You get it? So our total revenue will be equal to, so let's write the TR1 first, which is 500 Q1 minus Q1 squared plus 1.5 Q1 Q2. So the same thing here, that's for TR1. Then plus the TR2 plus 300 Q2 plus 1.5. Here is 1.5, not 15. So plus 1.5 Q1 Q2 then minus Q2 squared. All right, so here since you're adding, there's no need to put in brackets because it will be the same. All right, so now our final total revenue for both of them would be, so 500 Q1. Is there any other Q1? Here we're about to group like them. So Q1, there's no other Q1. So you maintain our 500 Q1. Then negative Q1 squared. Is there any Q1 squared? There's no other Q1 squared. So minus Q1 squared. Then 1.5 Q1 Q2. Then there's also another 1.5 Q1 Q2. So 1.5 Q1 Q2 plus this 1.5 Q1 Q2 give us 3. 1.5 plus 1.5 give us 3. So plus 3, then Q1 Q2. Then plus 300 Q2. There's no other Q2. So plus 300 Q2. Then this is the last one. So minus Q2 squared. So we are done. So ladies and gentlemen, this is the final total revenue function or the joint total revenue function. 500 Q1 minus Q1 squared plus 3 Q1 Q2 plus 300 Q2 minus Q2 squared. So now that you found the joint total revenue function, we can now find our profit. We said the profit is total revenue minus total cost. So our profit will be equal to the total revenue. You get it? Which is 500 Q1 minus Q1 squared plus 3 Q1 Q2 plus 300 Q2 minus Q2 squared. So this is the total revenue. Then minus the total cost. So minus the total cost, the joint one was already given to you in the question. So no need to solve for it. Since they already added for you. So minus, and I feel that anytime you are subtracting and they are lost, try and put it in brackets so I don't make a mistake because the negative is affecting each and every term. So minus into brackets 100 Q1 plus Q1 Q2, right? Plus Q1 Q2, then plus 100 Q2. So plus 100 Q2. All right. So our profits will be equal to 500. Let's simplify this. So we are going to get 500 Q1 minus Q1 squared plus 3 Q1 Q2 plus 300 Q2 minus Q2 squared. Then here the negative will affect all of them. So negative 100 Q, then negative Q1 Q2, then negative 100 Q2. I hope you guys can see. You get it. So now our final profit function, we are going to group like terms. So 500 K1, is there any other K1? Yes, we have K1 here. So 500 K1 minus 100 K1 should give us 400 K1. The negative Q1 squared, is there any other Q1 squared? No, there's no other Q1 squared. So minus Q1 squared. Then plus 3Q1 Q2. Is there any other Q1 Q2? Yes, here. So 3Q1 Q2 minus Q1 Q2 give us positive 2Q1 Q2. So let me underline them so we know before we are done with it. Then plus 300 Q2. Is there any other Q2? Yes. So we have 300 Q2 minus 100 Q2. And that should give us 200 Q2. Then negative Q2 squared. Is there any other Q2 squared? No, we are done. So you've underlined all the things, meaning you are done with each of the things. So ladies and gentlemen, this is the profit function. 400 Q1 minus Q1 squared plus 2 Q1 Q2 plus 200 Q2 minus Q2 squared. Depending on how you do yours, any of them can come first. It depends on how you arrange it, you get it. And we're going to move on to the II, where we're asked to determine the profit maximizing output levels subject to the contract production quota. All right. So now we are going to use the same profit function. So please take note of it. In fact, I'll write it at the top so that you don't get confused. So let me clean the board so that we do it. So now we've been given, you already know the profit function. We solved for it. Do you get it? So now they are saying that we should find the output that will maximize the profits given or subject to the contract production quota. The contract production quota is a constraint that is given to you. You get it? And that was in the question. The question, they said a firm has been contracted to produce a total of 1,900 units of two goods. So the question is asking you, what's the maximum profit you can make if the total that you are making is 1,900 or the output that you are using is 1,900. You get, so if you are making gari and sugar, it's like if you use this amount of gari or if you use this amount of ingredient to prepare gari and you also use this amount of ingredients to prepare sugar, what's the actual or the maximum profit you can make? You get it? So now in doing that, you are going to apply our knowledge from quantitative methods in Lagrange multipliers. Do you get it? So now here I'm going to make it very simple since a lot of students have challenges with it. So now the first thing you have to do is that take your constraints. First, you might not be able to identify how to write a constraint. So just put your head, if they give you a constraint of 500 or even contracted to produce 500 units, whatever they've given to you, Q1 plus Q2 just equates to 500. It means whatever you're producing shouldn't exceed 500 or it should be exactly 500. You get it? So this one like this, they said Q1, they said a firm has been contracted to produce a total of 1,900 units of two goods, Q1 and Q2. So it means Q1 plus Q2 should be equal to 1,900. It's as simple as that. So assuming it was Q2 and Q3, so that means Q2 plus Q3 is equal to the number that they've given to you. All right. So now in doing this, we already have our Q1 plus Q2 is equal to 1,900. And please do it exactly how I'm doing it, else you might get a wrong answer. Do you get it? So now here, when you now know that your Q1 plus Q2 is equal to 1,900, equate it to 0. Do you get it? But then send this part rather to cross the equal to sign. Do you get it? So now you are going to get this Q1 plus Q2 is going to vanish, so it's only going to be left with 0 here. So you're going to get 0 is equal to, then the 1,900 will stay here. Then Q1 will cross here to become negative Q1. Then Q2 will cross here to become negative Q2. You get it? So this Q1 plus Q2 is equal to 1,900. Change it to 0 is equal to, then the 1,900 will come first, then minus Q1 minus Q2. In other words, just equate it to 0. Do you get it? All right, so the next thing we are going to do is that we are going to state a Lagrangian function. So in case in exam, you've been given a question like this, they can ask you to state a Lagrangian function. So this is what you state. So just bring your L, something like an L like this. Then it's equal to, then your profit function, the one we just solved for, which is here, just write the same thing. It's equal to 400 Q1 minus Q1 squared plus 2Q1 Q2 plus 200 Q2 minus Q2 squared. So now this is the profit function, what we got for the profit. After you write the profit function, then we are going to introduce a Lagrange multiplier called lambda. You get it? So you are going to bring a plus sign, then you bring lambda. This is like a Greek alphabet. Then when you bring the lambda, this is a Lagrange multiplier. So it's going to multiply your constraints when you equate it to 0. So plus lambda into brackets 1900 minus Q1 minus Q2. It might look difficult, but it's not so difficult. You just write your profit function, then plus the lambda. You get it, this sign, then times this one when you equate it to 0. That's all. So just multiply this times the lambda. That's why you call it the Lagrange multiplier. You get it? So now this function is called the Lagrangian function. So in case you're asked, so now we can even simplify it to make it easier. So we are getting our Lagrangian function to be 400 Q1 minus Q1 squared plus 2 Q1 Q2 plus 200 Q2 minus Q2 squared. Then here the lambda is multiplying all this. So plus lambda times 1900 is 1900 lambda. Then lambda times negative Q1 is negative Q1 lambda. Then lambda times negative Q2 is negative Q2 lambda. Do you get it? Then after here, the next thing you're going to do, they are going to differentiate with respect to all the variables here. There are 3 variables here. We have Q1, Q2, and lambda. You get, so we differentiate with respect to all of them. So now let's differentiate with respect to Q1. So you're going to get del L over del Q1. So now we are differentiating this with respect to Q1. So let's start. We have 400 Q1. So this will be 400. The Q1 will vanish. Do you get it? Then minus Q1 squared. So this will be negative 2 Q1. Negative 2 will multiply this side. There's nothing here. So it's like times 1. You get it? So negative 2 Q1. Then the exponent reduced by 1. So it's the same thing as negative Q1. Then plus 2 Q1 Q2. So we are differentiating with respect to Q1. You get it? So now if you are differentiating with respect to Q1, Q1 is multiplying Q2. Put that in your head. If Q1 is multiplying Q2, you are going to assume that Q1 is 1. You get it? So you are going to get 2 times 1 times Q2. You are going to get 2 Q2. You get it? So just assume that the Q1 is 1 when it's multiplying. That's all. Then plus 200 Q2. Because there's no Q1 there, this whole thing is 0. Minus Q2 squared. Because there's no Q1 in that thing, that whole thing is 0. Plus 1900 lambda. There's no Q1 there, so that whole thing is 0. We don't add it. Then minus Q1 lambda. This one to Q1 is also multiplying lambda. So you assume that Q1 is 1. You get it. So minus 1 times lambda. You're going to get negative lambda. So here will be negative. The negative lambda. You get it. Then minus Q2 lambda. There is no Q1 there. So that whole thing is 0. So when you differentiate with respect to Q1, you're supposed to get 400 minus 2Q1 plus 2Q2 minus lambda. Then after we equate it to 0, anytime you are finding for maximum, you always equate it to 0. Do you get it? So now we've differentiated with respect to Q1. We are going to differentiate with respect to Q2. So we have del L over del Q2. So now let's differentiate with respect to Q2. Let's start 400 Q1. If there's no Q2, that whole thing is 0. So here will be 0 since there's no Q2. Minus Q1 squared, there's no Q2 to be 0. Plus 2 Q1 Q2, there's Q2 there. But because you are differentiating with respect to Q2, and Q2 is multiplying another thing, we assume that the Q2 is 1. So you're going to get plus 2 Q1 times 1. And that will give you 2 Q1. Then plus 200 Q2. You are differentiating with respect to Q2. So that will give us plus 200. The Q2 will vanish. Then minus Q2 squared. So we are going to get negative 2 Q2 minus Q2 squared. That's what you are differentiating. So you're going to get negative 2 Q2. The 2 reduced by 1. So we get negative 2 Q2. Then plus 1900 lambda. There's no Q2, so that whole thing will be 0. Then minus Q1 lambda. There's no Q2, so that whole thing will be 0. Then minus Q2 lambda. There is Q2. So since Q2 is multiplying lambda, we assume that Q2 will be 1. So negative 1 times lambda. Then it will be negative lambda. Then we also equate it to 0. Then now we are going to differentiate finally with respect to lambda. So we are going to get del L over del lambda. And this should be equal to 400 K1, there's no lambda, so to be 0. Negative K1 squared, no lambda to be 0. 2K1, K1, 2K1, K2, no lambda to be 0. 200 K2, no lambda to be 0. Negative K2 squared, no lambda to be 0. Plus 1900 lambda. We are differentiating with respect to lambda. So now we are going to get 1900. You get it? It's like 1900 times 1, then lambda will go. Then minus K1 times lambda. K1 is multiplying lambda, do you get it? So we assume that lambda is 1, do you get it? So negative K1 times 1 will give you negative K1. Then minus K2 lambda. Lambda is multiplying K2, so we assume that lambda is 1. So negative K2 times 1 will give us negative K2. Then we equate it to 0. So this side, here is a trick. When you are differentiating with respect to lambda, you should get the constraints when you equate it to 0. So you realize that we got 1900 minus K1 minus K2. It's the same thing here. 1900 minus K1 minus K2. So it means that our answer is correct. Do you get it? So now we've got 3 equations. So I can make this equation 1, equation 2, and equation 3. Do you get it? So now that we've got these 3 equations, the next thing we have to do is that we have to solve them simultaneously. So we get a value for K1, K2, and lambda. That's our whole objective. You get it? So now, in solving them simultaneously, let me just help you solve it simultaneously. So I can do equation 1 minus equation 2. Do you get it? So equation 1 minus equation 2. You can do it step by step, but because of space, I'll just go. So now we have 400. This equation 1, this equation 2. So this minus this. So we have to subtract it 10 by 10. So 400, then here is 200. You get it? So 400 minus 200 will give us 200. So then minus 2K1, negative 2K1 minus 2K1 should give us negative 4K1. Then 2K2 minus negative 2K2. So we are getting 2 minus negative 2. You get it? That's the same as 2 plus 2. So you get plus 4K2. You get it? Then this whole thing should be equal to 0 because this is equal to 0, this is equal to 0. So if you are subtracting, we should also equate it to 0. Do you get it? Now that we've got the equation 1 minus equation 2 to be 200 minus 4K1 plus 4K2 is equal to 0. We can divide both sides or each of the terms by 4. You get it? So in dividing each of them by 4, 200 over 4 should give us 1, 2, 3, 4, 5, I think 50, right? If I'm not mistaken. Yes, 50. Then minus 4K1. 4K1 divided by 4 is the same as 1. You get it? So negative 1. So I can make a negative K1. You get it? Then plus 4K2 divided by 4 to give us positive 1K2. So the same as K2. So plus K2. Then this will be equal to 0. I can send the 50 to cross the equal to sign. So I'll have negative K1 plus K2. Then it should be equal to 50. When it crosses the equal to sign, to become negative 50. You get it? Then I can also add my constraints, which is K1 plus K2 is equal to 1900. So we also have K1 plus K2 equal to 1900. Then we can solve them simultaneously. So we have negative K1 plus K2 is equal to negative 50. So negative K1 plus K2 is equal to negative 50. Then we also have the constraint, which is K1 plus K2 is equal to 1900. All right, so here we can just solve both of them simultaneously. And when we solve both of them simultaneously, whether you use substitution, elimination, or even use the calculator, when you point this on the calculator, you should get K1 to be equal to, so our K1, which is our x, the first letter, is 975. Then our K2, which is our y, the second letter, should give us 925. So now we found our K1 and our K2. Let's also find for lambda. You get it? So we can just substitute it into this equation to find for lambda. All right. So 2K1 plus 200 minus 2K2 minus lambda is equal to 0. So we can have 2K1, 2 times 975 plus 200 minus 2 minus 2 is what? 925. Then minus lambda is equal to 0. So if you punch all this, 2 times 975 plus, let me do it on the calculator. So 2 times 975 plus 200 minus 2 into brackets 925. That should give us 300. You get it? 300. Then we can equate it to lambda. So this whole thing will give us 300. Then it's equal to lambda when we cross the equal sign. So it means our lambda is 300. Our K1 is 975 and our K2 is 925. All right. So for the where we asked the same the profit maximizing output levels. So the profit maximizing output levels are 975 and 925. The 300 is not part. Do you get it? All right, so just 975 and 925. Now let's move on to the II. The II, we're asked that how much profit would a firm make by producing to meet the contracted output. All right, so now this one we just have to substitute K1 and K2 into the profit function. You get it? Well, I think I cleaned the profit function, but then I'll write it again. So for the profit function, which we solved for in I hope you've not forgotten or you wrote it down. We got 400 K1 minus K1 squared plus 2 K1 K2 plus 200 K2 minus K2 squared. All right, so now this is our profit function. So we just substitute K1 and K2 into it. Do you get it? So our K1 is 975. So 400 times K1, which is 975, minus K1, which is 975, then square again, then plus 2 K1 K2. So plus 2 into brackets K1. Here is K1. So K1 is 975, then times K2, which is 925, then plus 200 times K2. K2 is 925, then minus K2 again, 925 squared. So when you substitute it into it, you should get, so let me do it on the calculator. You should get 572,500. So 572,500. So 572,500. So that was for the III, right? So how much profit would a firm make by producing to meet the contracted output? So this is the profit you will make. That's when you substitute the K1 and K2. All right. So you can add a unit as well, which is the CDs. Now let's go to the IVN. The IVN says that you should estimate the new maximum profit if the production quota increases by 1 unit. All right. So if the production quota increases by 1 unit, you just have to add the value of lambda to it. As in it was decreasing by 1 unit, you subtract the value of lambda in it. But since it's increasing by 1 unit, it's going to be 572,500. That's for the IVN, right? Then plus lambda, which is 300. And I think that should give you 572,800, right? So yes, if it increases by 1 unit, this is the value you are getting, 572,800 cedis. All right, now let's go to the VIN. The VIN says that assuming there is not restriction in terms of the production quota, what will be the output level that maximizes the firm's profit? Calculate the actual profit that will result from this output. So this one, they are saying that assume there was no constraint. If there's no constraint, it means you don't have to use Lagrangian and all that. So it means this profit, you have to maximize it without adding the constraint. Now, when you try and do it, you are going to get an error, but then let me just do it and show you. So I'm going to clean this part. So they are saying this is the profit function. Now, don't assume that you are supposed to produce 1,900. Let's just maximize this. So if you are maximizing this, we'll do with respect to K1 and K2. So get del pi over del K1 is equal to, you are differentiating with respect to K1. So you are going to get 400 minus 2K1 plus 2K2. Here, all here will be 0. Then del pi over del K2 should be equal to, here is 0, here is 0. Here will be 2K1. Here will be plus 200. Then here will be minus 2 kill 2. Then we are supposed to equate it to 0. We are supposed to equate it to 0. So when you try solving both of them simultaneously, I don't want to do it because you're going to get an error, but you can attempt. You realize that it won't be possible. So when you try solving and you're getting an error, you can just conclude that there's no finite maximum profit, or there is no maximum profit that a firm can make. What that means is that because there is no constraint, it can make as much as profit because the quantity has not been specified. Because you don't know the amount of quantity it's using. So as it's increasing the quantity, can make profit. So you can just conclude that there is no finite maximum profit, or there is no maximum profit since there are no restrictions or there are no constraints. You get? So that's how you can conclude. All right, so I think we are done with this question. Thank you very much for watching this video, and I'll see you in the next video.